Assalamualaikum students, also here welcoming you again to our online course of mathematics. Today we are going to define the limit. But as you know that we have already discussed a lot of things in that are present in this unit. First we discussed a bit of the neighborhood of a point. If we have a point, how we can determine the neighborhood of that very point. We have already discussed it. Now, going to the definition of this limit, we must have to take under consideration the meaning of several things. First, as you know that beta, this 0 less than this x minus delta less than c. This means, it means beta, this x belongs to deleted neighborhood of this c. We have already discussed it in the past lecture that this condition means beta x belongs to deleted neighborhood of c, and we also have the meaning of this very thing, x minus c. If it is less than delta, that means beta this x belongs to the neighborhood of this c. C plus delta. We write it like this. Now we will discuss the third meaning, that is beta. Third one, that is beta x tends to c. What it means beta? If we have beta a point c here, if we have a point c, if the values of this x, if we have the values of this x very close to this c, but not equal to this c. If the values of this x are very close to this point c, but are not equal to this c, then we say that beta this x tends to c. So what x tends to c means? X tends to c means the values of this x are close to this c, but not equal to this c. So if we will analyze it graphically, if we have this c as 2, then beta this x tends to c, if we have point x, the values of x as beta 1.999 so on, and x is equal to beta 2.00000 so on beta. I have taken a point c2, c equal to 2, and I am telling you beta, if I will take the values of this x 1.29999 so on, and x is equal to 2.000 so on. Now beta 00 so on up to 9 beta. Now if you have concentrated on these two values of x, you will find out beta the values of these x are very close to this c, but this x is not equal to this 2. So this time beta, I will tell, this time we will write beta this x is equal to 1.9999 so on. It tends to beta this 2, and this x is equal to 2.000 up to 9. It also tends to this 2. So here I got the two things beta. The values of x that are left of this c are also getting close to this 2, are also getting tend to this 2, and also the values that are right side this 2, they are also getting close to this 2. So beta, I can say that x tends to c. If x tends to c, it means x is tending to c from the left as well as from the right of the c. So we will write the meaning of this x tends to c first. After that we will discuss these two things which I am telling you. We will write them as a remark. So I will write here x tends to c means x takes values very close to C, very close to C, but not equal to C. X tends to C means X takes values very close to C but not equal to C. We know if we have this point C, here we have point C plus delta and this C minus delta. If we take this delta very small beta, very small, the values that are between this C and C plus delta and the points and the values that are between the C minus delta and C, they are close to this C, they are very close to this C. So I can say that beta, all the values that are between the C minus delta and C plus delta except in this C, they are tending to this C, they are tending to this C. So this condition is also similar to beta. I can write it as X tends to C implies X tends to C implies X belongs to this C minus delta to this C, but C we have to exclude C minus delta, and also union यहाँ से यहाँ तक, that is C plus delta. We can write this action to C also as this. So it also implies beta. When we check this, it is the definition of beta what? Deleted neighborhood of C. So I can say that when X tends to C, it means X belongs to the deleted neighborhood of this C. So here we write this meaning here, X tends to C implies X belongs to this C minus delta C union C plus delta, and I can say that this X belongs to deleted neighborhood of C. Why the delta is really small? Because if the delta is not small, then this condition will not get satisfied, because it will the values of this X will go very high, they will not get close to this C. So this is the meaning of this X tends to C. Now beta, we know that I have told you that sometimes this C minus delta is small C. Sometimes beta, the values of X that are left of this C, they are getting close to this C, and sometimes the values that are right to this C, they are also getting close to this C. So after the value from this C minus delta to the C minus delta to the C, these values are getting close to C, close to this point C. They are tending to this C, but these points are towards the left of this C, and we write at that time beta X tends to C negative. ऊपर हम ये माइनस लगाते हैं, इसका मतलब होता है कि जो x के वैल्यूज है वो लेस देन होते हैं c से, लेकिन क्लोज वो c को ही जाते हैं. सो आई कैन से दैट दिस x टर्म्स टू c मींस बेटा x बिलोंग्स टू दिस c माइनस डेल्टा comma open interval c minus delta comma c. Similarly beta, sometimes the values that are between this between that are greater than the c, or that are between c and c plus delta, they are getting close to c, and that time we are writing with x tends to c positive, which implies beta x जो हो उसके values होते हैं उस time c comma c plus delta. These two. So now beta, we write these two as remark. For this meaning beta, you can represent it on number line for your ease beta. If you are C, if this is C minus delta, while यहाँ पर लिखना आपको delta is very small, and here C plus delta. All the points that are between the C and C minus delta, they are getting close to C, but except this C. So similarly beta, for these two, we will write them as a remark. This was our third meaning beta. Now we write two remarks that will help you to understand the things I have discussed. Remark first. remark first, I have told you beta, if we have beta this point C, and if we have here C minus delta, C plus delta. The point is that are between the C minus delta and C, they are getting close to the C but from the left of C, and at that time we write beta this extends to C negative. So यही मैं लिखूंगा x tend to C, x can tend to C when x can tend to C when the values of x are, when the values of x are close to C from the left of C, or I can say that x can tend to C if the values of x are smaller to C. You erase it better, you write here x can tend to C you write here by correct. X can tend to C by taking values of x smaller than C, x can tend to C by taking values of x smaller than C but not equal to C. We write it. We write this as x tends to C negative. That means beta x tends to C negative if and only if x belongs to this. I have told you C minus delta comma C. If x belongs to this, but what it means is beta if and only if, this means beta x belongs to left deleted neighborhood of C. I have already given you the definition of left and deleted neighborhood. So for your ease, you can take it on number line. If this is point C, this is C minus delta, this C plus delta. All the points that are between the C and C minus delta, they are in the left of the C, but they are getting close to the C. We write here x tends to C negative. Similarly for this, for the points that are between the C and C plus delta, we write x tends to C positive. Here we write C negative. This is the first remark. Now you write down second remark. Similar to this remark, beta x tends to C positive R if and only if this is the second remark, beta I am not going to write it fully. You have to write it completely, but I will just say you some little. X tends to C positive means x is taking the values close to C, but the value that x takes, they are towards the right of this C. If and only if x belongs to beta, as I told you, C plus delta. C plus delta, open interval of C and C plus delta. If and only x belongs to, we know that this is the right deleted neighborhood of C, right? So for your ease, you can again draw one number line. This is C minus delta, this is C plus delta, and the value that is between the C, we write them external to C plus. Now we will come to our definition of limits. Definition. First definition. Beta, if we have a function f of x, and if we have a point C such that the values of this x are tending to this C, x tends to this C, x tends to this C. So beta, if the values of this x are close to this C, and if at that time the values of this f of x are getting close to beta some point, that is some real number or some point, that is L, at that time beta we are saying this f of x has limit this L. Or if this is our C and the values of this is the values of x are close to this C, if at that time beta the value of this function, f of x, if they are getting close to this L, we are saying that time beta this limit of this f of x, limit of this function f of x at this point C is equal to beta this L. Or we say beta when we are tending this x to C, our function is getting tend to this L. We can write it like this beta. We know that beta this means when we write this x tends to L, it means beta the values of this f of x are getting very close to this L. So when the values of this f of x are very close to this L, when the values of this, for example this is f of x, this is our x tends to C, this is our f of L. When the values of this f of x are tending to this L, tending to this L, when they are getting when the function is getting close to this L, we say beta that time beta this f of x has limit L at जब हम x को टेंड करते हैं C को, and we write it beta, I have told you limit x tends we write it like this, limit x tends to C, f of x is equal to L. But beta, if you analyze this condition, it is making us aware beta this function is getting close to, so the values of this function must be very near to this L. Or we can say that if we have neighborhood L plus epsilon, L minus epsilon and L plus epsilon, we can say that beta this, the values that are between this L minus epsilon and L, they are getting close to this L, and beta at that time beta, if you analyze it, this function, the values of this function, these that are close to this x L, the distance between this L and these values of function, the values of this function at this point is beta, it is very small beta, it is very small, it is just negligible beta, because when it is negligible then we can say that beta the function is getting tend to this L, because otherwise it is not successful. So beta I can say that x tends to C if f of x minus L, value of function minus L is less than epsilon, or I can say delta is less than epsilon, but epsilon is very close or it is negligible. If the distance between this L and the values of this function is very small, is negligible, then we say that beta L is the limit of this function. So in nutshell we write the definition. So what we got? f of when x tends to c, f of x tends to L implies this f of x minus L less than epsilon, while epsilon is small, so and we write it beta as limit x tends to c, f of x is equal to L. We write now this definition. Alright, let f be a function defined, let f be a function defined for all x close to c except possibly at c, then this L is said to be limit, L is said to be limit of fx as x tends to c, as x tends to c, if distance between f of x and L is very small, or in fact negligible. That means beta, that means f of x tends to L as x tends to c if and only if distance between this f of x minus L less than epsilon, while epsilon is very small. Or we can say that beta, this condition we know that it means beta f of x belongs to L, open interval of L minus epsilon, L plus epsilon, L minus epsilon, L plus epsilon as x tends to c. This is our definition of function. You must have got this point beta, because I have given you the meaning of when this condition is satisfied. What is the meaning of this? This was the definition of limit beta. Now we will define two more things, and after that we will close today's lecture. It will be enough today for you. Left hand limit. Left hand limit. This very thing we are going to define now. Beta. We know that beta, if this is our point C and this is C minus delta and this is C plus delta. We know that the points that are between the C minus delta and C, we are taking them as x tends to C, x tends to C negative, x tends to C negative. If we will take the values of this x as C, open negative, if we will take them as the values that are between the C minus delta and C, and if the function at these values tends to the L, tends to this L, then we say that beta this limit x tends to C negative f of x is equal to L. We call this beta, this limit we call at that time beta left hand limit. Similarly beta, when we take the values of this x from the C to the C plus delta, at that time beta the limit of the function we call that right hand limit. We will write these two definitions. Let f be a function defined. We know that what this x tends to C negative means, it means beta x belongs to the left deleted neighborhood of C. So I will take here this. Let f be a function defined in left deleted neighborhood of C. Then L is said to be left hand limit of left hand limit of fx as x tends to C as through values less than C. So it is the definition of left hand limit, and we write this beta as limit x tends to C. When we tend this x toward the left of the C, f of x we write it as L, or we write beta f of x minus L, that is less than epsilon for all x belongs to beta this left hand, that is beta C minus delta C. Similarly beta, after that we can define right hand limit. Right hand limit. Right hand limit, you write the definition by yourself. I will just give you the something here. That is beta, if we tend this x to C positive now, then beta f of x tends to L is called beta right hand limit of this f of, and we write it as limit x tends to C negative f of x is equal to L, or we say beta f of x minus L, the distance between these two is less than epsilon, where epsilon is for all x now belongs to deleted neighborhood of C, right deleted neighborhood of C, that is C plus delta. So this is, and for your ease beta you can beta how this has C minus delta, this is C plus delta, x tends to C negative this, f of x is equal to L, this is called left hand limit, and if we have C minus delta, C plus delta, f of x at that time, if x tending to this c positive, here f of x is tends to L minus beta. Negative is equal to here f of x. We call this beta right hand limit. Okay, beta, it is enough for today. Inshallah, Rahman, tomorrow we are going to solve some examples that are based on the limits, and we will find out some rules that will help us to find the limit of a function. Okay, it is enough now. Have a good time ahead.